Hello, this is the 20th lecture in the Psychology in Action series. Today we're going to go over your lab report and how to lay it out in different sections and what to put in each section. We'll run through a t-test, or at least one of the types of t-tests, because there are several different types, but we'll only look at one type today. How you would work the maths out for that. So if you want to pause this recording and go and get yourself a calculator, and maybe some scrap paper and a pen, so you can keep track of it as you go along and perhaps do some of the working out. Although it's all done for you on screen, it might help for the maths to sort of sink in if you have a go at doing some of it yourself, so you can get the gist of how it works. And then we'll finish by looking briefly at Vygotsky's language theory and how some of the different language theories could be utilized in your laboratory report. There'll be an announcement going up on the module page regarding the submission date for the lab report, which I'll write that up in the announcement section. And given the way things seem to be going with the global situation, it seems somewhat unlikely that we will be back in class in sufficient time, at least, to actually be conducting the experiments in class. So I'm going to make an executive decision on this one, and I will put this as an announcement as well for anyone who is not paying close attention to these recorded PowerPoints, that if a member of your group can contact me, and I'll repeat this at the end just as a reminder, if a member of your experimental group can contact me and let me know the details of your experiment, which we'll get to at the end, what I need to know, I will then generate some obviously imaginary data for you to work with. And then you you write up your report as if you had done the experiment for real. And I think, unfortunately, this is about the only way we can get around this at the moment that's going to work practically. It's a shame that you don't get to do the experiment in class, but obviously circumstances are beyond any of our controls at the moment, and so this, I think, is perhaps the next best alternative to being able to do it for real, is I send you a set of stats and you work with the stats that I send you. And we'll do it on that basis. Okay, so your lab report is 1,250 words, and it needs to consist of these various sections. It needs to have a title page, an abstract, an introduction, a methods section, a results section, discussion section, your standard references, and an appendix at the end. We'll get to what, as we go along, what you need to put in your appendix. Now, the standard layout for a lab report, and whilst this isn't some sort of massive issue for me personally, I think it's good practice for you to get into the habit of doing it in the formal way, so that if you pursue academic studies onto master's level and so forth, or get a job that involves any degree of experimental research, you'll already be in the practice of doing it in the formal way. So you stick to the third person pronoun throughout. So rather than saying, we did this, I thought that, you would write, the experiment was conducted in so-and-so way, or the researcher hypothesizes that. So you never refer to yourself as I or your group as we. You always keep it in the third person. And if you're at all uncertain as to what the third person is within a given situation, you can always ping across the as much of the lab report as you've written and say, have I used the correct pronouns in this section, and I'll tell you whether you have or not. Likewise, you can also contact Ben Farrell or Anita Rooney, and either of them will go through your pronouns and tell you what needs to change and what doesn't need to change in your pronouns. And the other bit you've got there, the font size should be 12, and you're meant to either double space or 1.5 space a lab report. That's going back to the days when people would, lecturers would write by hand on a paper copy either flattering or rude comments about your work and would squeeze the commentary in between the lines, even though it's all done electronically nowadays and you no longer have rude things written on your printed out reports. No, it's still nonetheless the sort of standardized practice for either 1.5 or double spaced. So if you just keep it to that format, that would be lovely. Now, section by section, your title page should include the title of the report. So that could be an experiment testing the impact of visual imagery on language learning, or something like that, depending on quite the nature of your experiment, what factors and variables you're testing. So you would come up with a title like that. Not everybody in your group needs to use word for word the same title, even though you're obviously conducting the same basic experiment. So you could slant it in different ways from each other. You don't have to slavishly follow the titles that other people have used. Put your student number, not your name, obviously, because all work should be anonymous, but put your student number, this thing would stop bugging me, put your student number on there, and your professional address. In this case, your professional address is the School of Applied Social Sciences, University of Suffolk, West Suffolk College. Name a lecturer, that would be me, and the date on which you submit. That's the actual date on which you submit, not necessarily the deadline, because you might be getting it in a day or 2 or 3 before the deadline itself. So whatever the date of submission is, put that date on. Then go into your abstract and introduction. So this needs to be on a separate page from your title page, so you move on to a clean sheet, as it were, within your report. An abstract shouldn't be more than 100 words. The introduction is longer, but the abstract shouldn't be more than 100 words. It should be quite short. Now, the idea of an abstract is that somebody who either downloaded your work online or read it in a library as a part of a journal article, for argument's sake, they'd read the abstract, and that should help them decide whether or not they need to read the rest of your report. In other words, they're looking for information about a certain topic, and they need to see in your abstract, is this relevant to the certain topic I want to know about? If it is, I'll read further. If it's not, I'll shove it back on the shelf and find something else to read. So it should be just enough explanation that they know if it's worth continued reading. So state in the abstract what the experiment is about. Very briefly say how many people were involved in the experiment itself, and I will let you know that when I send you the statistics for your usage in your write-up and your report. And summarise the findings. That should be a 1-sentence thing right at the end of your abstract, saying the hypothesis was upheld or rejected, as the case may be. And you won't know that until you've actually done all the maths and worked that out. So usually that's one of the last things that gets written, is that single sentence at the end of the abstract saying what the findings were. Then you go into your introduction itself, and broad introduction to the topic, the area of language acquisition. You don't need to cover every theory going, just the theories that are particularly relevant to you, because this is the lit review, the reports that other people have conducted on similar areas. So if, for example, you are looking at the impact of reward systems on language learning, every time they get a word right you give them a sweetie or something, then you would be looking specifically at any other research also conducted into the area of reward as an incentive for learning language. So you wouldn't be branching off into other unrelated forms of language research. You'd keep your lit review to things that are specifically quite similar to what you're looking at. Then say what your experiment is adding to. Now obviously this is more of a practice experiment than a real thing. So no one's expecting you to be the next Einstein and revolutionize understanding of the subject, but just suggesting maybe you're taking a slightly different tack, a slightly different angle from previous research. So you're looking at a variable that perhaps other people haven't looked at previously. The aim of your research would be to explore, for example, the impact of reward on language learning, or the impact of visual imagery on language learning, or the impact of conversational style on language learning, something of that sort. And your hypothesis would be that, again, a single sentence there, and it's got to be related to your aim. So your hypothesis could be something along the lines of, it is hypothesized that rewarding learners will improve their memory compared to unrewarded learners. That's not very grammatical, never mind. So it's a prediction that can be proved or disproved, in other words. So a hypothesis needs to be something where you can, at the end of the experiment, say either yes, the hypothesis was correct, or no, it was wrong. A yes or a no. Now, because this is an experimental design, you also include a null hypothesis, and the null hypothesis should be almost identical to the hypothesis word-wise, except it says there is no effect. So if your hypothesis is that a group of people will remember more words if they are rewarded than if they are not rewarded, then your null hypothesis would be that reward makes no difference to the rate of words learned. So in effect, kind of saying the opposite. One says this might happen, the null hypothesis is no, it won't happen. And if you're not too sure about the wording of your hypothesis, again, send me an email or contact me by some other social media means and say, this is the hypothesis we've got, have we worded it correctly? And I can suggest to you whether you need to change the wording or not. Okay, you then go into your method section, and your method section needs to be broken down into a number of subsections here. Design. Now your design section should say whether it is within or between groups. So is it within groups is that you have all of the class in condition A and then all of the class in condition B. Or between groups, you split the class into Group A and Group B, and Group A does one condition and Group B does the other condition. So which design have you gone for? So just state that as a sentence. This experiment uses such and such a design. For an added point in your grade, to bump it up a little bit, if you can justify the choice of your design. So if you just state what it is, you get a basic grade. If you can justify why you have gone for that design rather than a different design, and perhaps cite some theorist like Kulikan, for example, you could look at one of his books, a lot of his stuff is online, and suggest why this is a useful design to use for that sort of an experiment, to find out that sort of issue. Then, still in your design subsection, state what the independent variable is and what the dependent variable is. So, for example, the independent variable could be whether or not they get rewarded with sweets, and the dependent variable could be how many words they remember off a list of foreign words that they've been taught to learn. How many they get correct, something like that. Your participants, I'll tell you what your participants are. I'll give you the details when I make up these stats. But that will be shaped by the information you send to me. So if you decide you want to compare how men learn to how women learn, or you want to compare different age groups, say teenagers learning versus middle-aged people learning, then you've already shaped to an extent your choice of participant when it comes to things like gender ratio, age range, and so on. But I'll tell you how many people took part in this, unfortunately, imaginary experiment. You have to decide the sampling method. So would you, if you were doing this for real, would you be engaging in a random selection of people? Would you be engaging in a stratified selection, so many men, so many women, etc.? How would you be choosing people? And again, just stating what the sampling method is will get you a basic grade. Looking at the strengths and weaknesses of the sampling method will get you a slightly higher grade. And then you state the gender ratio, X many men, X many women, and the age range, youngest to oldest. And I'll tell you what the age ranges are when I send you the theoretical stats for this. You then move on to the apparatus and materials section, where you talk about what you have used, or at least what you would have used if you'd conducted the experiment for real. So that might be, for example, a list of words, and you would put your list of words in the appendix, the foreign words that the people were expected to learn, or the nonsense made-up imaginary words that they were expected to learn, as the case may be. If you, oh God almighty, if you want to use imagery, let's say you've shown people a picture of a cat and then taught them what the Japanese word for a cat is, then you would include a page in your appendices showing the images that you have theoretically shown to these experimental participants. If they had a piece of paper and a pen and they had to write words down on the piece of paper, then you would have a page in the appendix going word 1, word 2, word 3 or whatever, and showing the blank spaces where they would have to write that down. Now, your procedures section, the next bit on, is step by step. So what would happen step by step? So you invite people into the room, you direct them to sit down, you read them the brief, which is an explanation of what they need to know in order to take part in the experiment. You then maybe split them into 2 groups, or you have them all in 1 group, however you're going to do it. Perhaps you either, somebody stands at the front of the class and reads out some words, and then they have to wait 2 minutes before writing the words down, or you show them images and you read out words, or however you're going to do it. What would you be doing? Now, you have to include enough information in this step by step by step, so that another person who just picks up your report and reads it could, if they so wanted, duplicate your experiment and do exactly what you did, step by step by step. So, whilst it's normally written in a slightly telegrammatic way, nonetheless it's just enough information that each person, that anybody reading this, whoever they are, could follow it step by step, could repeat your experiment. And finally, you have a subsection of ethics. Now, your primary ethical issue here is anonymity, that you're not naming any of the people participating in your experiment. You just refer to them as participant 1, participant 2, participant 3, and so on. But you might also have to think about issues of harm. So the words you're reading out, you might make a conscious effort to ensure that none of them are swear words, so nobody's offended. If you're going to show images, you might make a conscious effort that none of them are rude or insulting images, or possibly, let's say, one of the images is going to be a spider, for example. You might double check at the start of the experiment, is anyone arachnophobic? Are they likely to freak out if they see a photograph of a spider? Something like that. Equally, if you're expecting them to write things down as part of the experiment, then you might need to check ahead of time, are any of them dyslexic? If they are, would they prefer to have pink paper, green paper, blue paper, what have you, so that it's easier for them to participate in the experiment? And another thing you need to factor out, of course, if you are trying to get people to learn words in Spanish, for example, you need to check up front, do any of the participants actually speak Spanish? Because if they do, then clearly it's not really going to work as an experiment for them, because they already know what those words are, probably. So that's, and it doesn't sound like an ethical issue, but it's to do with ensuring everyone is on a level playing field, so that everyone participating in this experiment starts from not knowing the language you're about to teach them. No one has an advantage that would screw up the experiment. The link you've got on the screen there, you can go on to the uploaded PowerPoint, the unnarrated version of this, and click on that link, and it will take you to the British Psychological Society's website and the part of that website that has their code of ethics and conduct on it. And you can have a look through those ideas and think to yourself, do any of these issues apply to my experiment? And then put them in. And when I say your experiment, you're in groups, you don't have to agree with each other on what the ethics are. Now, the procedure should theoretically be the same for all of you, because you're all conducting the same procedure, you're all using the same apparatus, you've all got the same design, you've all got the same participants, so that's going to be much of a muchness. but how you interpret the ethical issues, well, you might think something is an ethical issue, but another person in your group might not think it's an ethical issue, and that's fine. You don't have to agree point for point on the ethics. You can have your own view on this one. Part of the method is that you also state how you generated your data. How was the numbers found? So is this ordinal data? Is it nominal data, etc.? And what does the data reflect? Number of words remembered, correct pronunciation, or is it to do with correct spelling of foreign words? Quite what is it that you are marking these people on? It could be how long it takes them to do a certain task, like find, if you've given them a list of a big list of words, and they've got to find specific words on the list that they heard you say 2 minutes earlier, then it could be the speed it takes them to complete the task rather than how many they get correct that you're looking at. So there's different ways of evaluating and generating data. So quite how have you done it? That's the other element you need to state there. So if you're not too sure about the sampling, here's a quick overview. 4 different types of sampling here: random, stratified, systematic rather, and cluster. There are other types of sampling out there like snowballing and so forth, along with some of the points in favour and the points against those. So you could cite some of these as issues to flag up, or you could choose one of these sampling techniques, or you might prefer a different sampling technique to go for. Entirely up to you. But this is just a reminder. We have touched on sampling in the past, so this is just a brief reminder of some of the issues. So I won't go over the table because you can sit and read through it yourself and decide what's relevant and what's not to you and your experiment. Then you get into your results section, which should be short and to the point, and your discussion section, which is a bit longer and a bit more wordy. So the results section is where you summarize the statistics, what you found. So whether you're using a t-test or a p-value, that does depend on which type of statistic you're looking at. So you would effectively be saying something along the lines of a Wilcoxon's test was found and was used, and the value found was something point something something, and at the p-value of 0.05 this was either valid or invalid. Either it upheld the hypothesis and rejected the null hypothesis, or the other way around, it rejected the hypothesis and upheld the null hypothesis. So if it upholds the null hypothesis, that means you haven't found any statistical significance. You've done all the maths and it turns out your experiment doesn't prove much of anything. Now, you don't lose any marks if your experiment proves nothing, because your grade is for how well you've written the experiment, not whether it succeeds in proving anything or not. So you quote the stats, and then you say whether or not the hypothesis was upheld or rejected. This is where you could include a graph or a table, potentially. If you do include a graph or a table, make sure it is correctly labelled and explained. Don't just stick a graph in there and not say what it means. So even if it's only a sentence or two to explain what it means, that's what will get you the extra points in your grade. The clear explanation. A table with no explanation isn't going to gain you a good grade. And you can refer to the mathematical workings that you've included in the appendix and any big tables there. So normally the kind of tables you would put in the results section would be a very small table. If you've got lots and lots of data on a graph, that goes into the appendix, but we're coming to the appendix momentarily. So keep that results section short, to the point, focused. The discussion section is where you can expand a bit in terms of word count. You're trying to explain why you got the result you got. Now, if your hypothesis has been proven, what does this say? What theories help to explain why the hypothesis was proven? Equally, if the hypothesis was rejected, your experiment didn't prove anything, why not? Is there a flaw in the design of the experiment, or is it that the theory just is not a particularly good theory and some different theory is perhaps stronger and more likely to explain evidence and explain how people learn language? What would be the issues here? So you bring in some theories and try to include at least one or two of the theories you mentioned in your lit review in the introduction. So you're bringing back the same names and saying, well, either this theory is correct or this theory turns out not to be very good, as the case may be. Bringing that back in. And you normally finish your results section with a recommendation for future research, which could be a similar experiment, but a slight tweak here, a slight tweak there. If we change this bit, change that bit, we might get slightly different results. So you then make a suggestion that an aspect of future research could be ... Okay, then you have your references and your appendix. Now the references are a standard for all references. The appendix section should include these things. Your raw data, so that's the statistics, the actual scores people got in the various different conditions. So a table showing the scores and making sure the columns are correctly labelled. So condition A, condition B, etc. Then a page of your statistical workings. That's the adding up, dividing, taking away, relevant to the type of statistic you've used. And once you've told me, or a member of your group has told me, what design you are using, I will point you in the right direction for which statistic you should be using. And you can then disseminate that information to the rest of your group. And if we haven't already covered that in lecture, I will upload a separate lecture covering that specific type of statistic for your group, so you can sit and work it through for yourself. But it's just a page of maths working out, basically. Essentially, it's there to show you haven't just made up a random number out of thin air, you have actually done the maths. Examples of any materials you've used, as I said earlier, that could be examples of photographs you've shown to the participants, it could be the list of foreign words you've got them to try and learn, whatever things you've used in the experiment to get them to understand and grasp for the experiment. Then a copy of the brief, that's the short paragraph you read out to the people at the start of the experiment so they know exactly what they're expected to do. And the debrief, which is another short paragraph which you read out to them at the end of the experiment when it's all finished. And basically you say, thank you very much for participating in this experiment. If you have any further questions, contact yourself or me as the class supervisor. And you can also say, well, do you have any questions now? If so, we can address them. If not, thank you very much. There's the door. I will upload into the Brightspace page examples of consent forms, examples of briefs and debriefs. The consent form is just a slip that normally they would have to sign saying, I am over the age of 18 and I agree to participate in this experiment, and they sign it. Now obviously, because we're not able to be in a room with people and get them to sign it, you don't have to get these signatures because these are all going to be imaginary people participating in your experiment. But for an experiment carried out under more normal circumstances, you would be getting them to sign those things and then keeping them safely in a drawer somewhere should anyone ever want to see the signed participants' forms. Or the Roman numerals bit there, so for example the raw data might be page 1, statistical workings, page 2, examples could be page 3, page 4, however many examples you've got. And you just use Roman numerals for those pages, and then when you are referring earlier on in your report saying, oh, see raw data on page 1, you always write it in the Roman numeral. That's just a standard convention. Ultimately it could, I don't know why, to be honest, Roman numerals, but that's just the standard convention. Probably a hangover from the days of classical education. Now, if you've got any questions on that bit, then there is the chat room set up this afternoon at, what time are we? 3 o'clock, that's set up for today. And if you're not able to participate in that one, you can email me, or I can set up another chat room, perhaps tomorrow, for example, for you to bounce questions around about your experiment and to let me know the details of your experiment as well. Okay, this is where you're going to need your calculator and your scrap paper and pens, and maybe a rather strong coffee. because we're going to have a look at using a t-test. And I'll take you through the maths, and I'll suggest if you pause screens every now and then to sit and scribble things down on your notepad and try and work out some of it for yourself. So even though it's on screen, it's good practice, it's a good learning technique when it comes to maths, to do things for yourself, even if the answer is right there in front of you on the screen, because then it helps you learn how these statistics work. So simplistic forms of research, which are relatively basic, relatively straightforward, commonly make use of t-tests. So a t-test is, and there's a number of different types of t-tests, we're going to look at one today. A parametric test, that's where you assume your sample population is fairly normal and has fairly average scores. There's nothing unusual or peculiar or remarkable about the body of people you have drawn your participants from. They're just standard people off the streets. And you're looking at two conditions, condition A, condition B, and the mean score of condition A, the mean score of condition B, and comparing them to see if there is a noticeable difference between the two. You can also alternatively use a Pearson's correlation coefficient. We will get onto that in a future lecture, which looks at the amount of relationship, correlation in effect, between two variables. So is there a pattern? In other words, if one goes up, does the other one go down? Or if one goes up, do they both go up? And if one goes down, they both go down. So is there a pattern, a fluctuating pattern between factor A and factor B, variable A and variable B? But we don't need to think about Pearson's today because we're going to focus on t-tests. So to give you an example of how this might work, a theoretical experiment here, imagine you've got a body of people who are unhappy, suffering from a bit of depression, and you divide them into two groups, and you give one group medication and the other group a placebo, something that looks like a pill but is just basically a sweet. It's a sugar pill. There's no actual medication in it, and none of them know who's in which group. So you just give them the pill and they take the pill, and you measure their depression risk. So you score them on depression. How sad are you today? You get them to fill in some kind of form stating how sad they are today, and you measure that over a period of 4 weeks. And your hope, perhaps, is that the people on medication will become gradually less depressed than the people on the placebo over the course of the 4 weeks. And so you're averaging the scores of the people in Group A to the scores of people in Group B. Now, you know who's in Group A and who's in Group B, but the participants themselves wouldn't know that, which group they're in. So you'd be looking at a pattern there. Now, an alternative approach, and the one we're going to use here for the sake of this statistic, is another imaginary experiment. So you've got a medication, brainiac pills. There we go. That's a very witty and stunningly original bit of humour there. Not. This pill is meant to improve memory. So you've divided them into two groups. Sorry, start that again. Different experiment here. So you've got a group of people, you give them a memory test, you work out how good their memory tests are. That is the pre-drug condition. So 10 participants, the first column there on the left-hand side, the middle column, the pre-drug condition, that's how well they did on a memory test, trying to memorize up to 15 different things. So the highest score they could have would be 15, the lowest score would be 0. And then you give that same group of people the medication. You give them the pills to see, do the pills improve their memory? And then after they've swallowed the pills, you put them in a room and you give them another memory test, and again see, does their score go up, does their score go down, does their score stay exactly the same? You're interested to see what kind of impact these brainiac pills have on their capacity to remember things. So that's what you're testing, and so the final column, the post-drug column on the right-hand side, shows how well they remembered things from a list of, let's say, 15 pictures or 15 words, whatever it happened to be, 15 phone numbers, who knows, after they'd taken this magic pill to see what it does. So we're going to test this. Now, the equation in the white box there is the one we're going to do. And again, some of you might be going, "Whoa," at this juncture, but never mind. We'll go through it step by step by step, and by doing it step by step, it will become more manageable than just looking at an equation full of symbols that may not mean an awful lot. And hopefully this is where you flash back to last week's lecture and remember that that symbol in the white box that looks like a letter E, a little bit, is actually the Greek letter sigma. And sigma means the sum of a group of numbers added together. The total of a group of numbers all added up. That's what that means. Hopefully you will have recollected that. Now, before we go forward, and when you write your hypothesis for your experiment, you'll be making a decision here, and you can make your own individual decision. You don't have to go along with the views of other people in your group on this one. Are you going to do a one-tailed test or a two-tailed test? Now, a one-tailed test makes a prediction that the results will go in a certain direction. Two-tailed test says, well, we hope there's going to be some result, but we don't know what it is. Could go either way. Keeps it open. The only real impact of these tests, one-tailed, two-tailed, is you use a different column on the chart to find out whether your statistic means anything or not at the end of the maths. So a one-tailed test would be predicting that the Brainiac pills will definitely improve memory. In other words, going back to this page here, so you would expect the numbers in the right-hand column to be higher than the numbers in the middle column, essentially. That's what a one-tailed test means. A two-tailed test means, well, you don't know. Maybe the pills will improve memory. Maybe the pills will make memory worse. Maybe they won't do a damn thing. Who knows? Could go up, could go down. If they don't do a damn thing, that is the null hypothesis. You've taken the pill and it hasn't made the slightest bit of difference. Their memory is about roughly the same. It's not up, it's not down, it's about the same. That is the null hypothesis. So one-tailed definitely goes up. Two-tailed could go up, could go down. Not sure. Okay, so the table on the left-hand side here. We've already given you these numbers on the earlier screen. What you're doing here is working out the means, those numbers in bold. So in the middle column, the pre-drug column, what you would do is add 11 plus 12 plus 11 plus 10 plus 9 plus 10 plus 11 plus 12 plus 9 plus 11. You'd add all of them up together and then you would divide by 10 because 10 is the number of people participating in the experiment. And if you want to pause it, do that for yourself. Bit of paper, bit on a calculator, on your fingers and toes, whatever is easiest for you. The number you will come up with, hopefully, is 10.6. Which you can see in bold at the bottom of the middle column, where it says mean. And likewise, you do exactly the same for the post-drug condition. Condition A, condition B. So post-drug is condition B. So you add 14 plus 13 plus 15 plus 11 plus 11 plus 12 plus 14 plus 15 plus 11 plus 13. Add it all up. Divide by 10, the number of participants. And the mean score on your calculator or doing it on paper, whichever you find easiest, will come out as 12.9, which again you have in bold at the bottom of the column there. So far so good, hopefully. You then, in the table on the right hand side of the screen, add 2 extra columns in. Now, the column that just says D at the top, the one that comes after the post-drug column, what you're recording there are the differences between the number in the in the condition A, pre-drug, and the number in condition B, post-drug. So if we go across the line at the top, the difference between 11 and 14 is 3. The difference between 12 and 13 is 1. So you record all of those there. Difference between 11 and 15 is 4, etc, etc, etc. So that goes across, and you can see in the D column in bold print, you have those differences. Now, it's worth noting that the differences are always a little bit higher, that the post-drug column condition B, all of those numbers are a little bit, some of them only a little bit, some of them several bits, higher than the numbers in condition A, the pre-drug. Now the final column on this table, where it says D squared, you take the number in the D column and you multiply it by itself. So if we start at the top, where you've got the difference between 11 and 14 being 3, you do 3 times 3, that gives you 9. Column below that, 1 times 1, gives you 1. Below that, 4 times 4 is 16, and so on, all the way down. So whether you're happy to take it as read, because it's on the screen here, or you want to have a go at doing that yourself, just to help learn the routines, the practices, maybe pause the screen and do it, up to you. Whatever helps you best with learning it. If we were in class, I'd be throwing a brand new set of numbers at you so you could have a crack at doing this all by yourself after I've gone through it on the screen. But as I'm not there to hover over your shoulder and go, oh, you're doing that wrong, or well done, you've done that correctly, then it seems a little mean to expect you to do that at home necessarily. And so we move on to this screen. Now in bold font, we're at the bottom of the bottom right hand corner of the table there. So we are multiplying the sum of D2 by the number of participants. So first off, we have to find the sum of D2. Sum of D and then the sum of D2. So column D, we're adding 3 plus 1 plus 4 plus 1 plus 2 plus 2 plus 3 plus 3 plus 2 plus 2, which gives us 23. And then in column D squared, we're adding 9 plus 1 plus 16 plus 1 plus 4 plus 4 plus 9 plus 9 plus 4 plus 4, which gives us 61. So far, hopefully, so good. Then, going back to column D, right at the bottom there, where we've got the number 23, we have to multiply that, we have to square that. So we need to square 23, it's 23 times 23, which you could do on your calculator, for example, and you will find is 529. Okay. Having worked all that out at the bottom, we now need to multiply the sum of D squared by the number of participants. So the sum of D squared is 61, the number at the bottom of column D squared, that we've just worked out. Number of participants is 10. So 61 times 10 is 610. So far so good. Now subtract the sum squared, that's 529, where it says at the bottom of the table sum squared. In the left-hand side of the table it says sum squared, and that gives us 529. So subtract sum squared of column D from the above answer, so the above answer being 610. So 529 minus 610 gives us minus 81. Minus 81. And I should have pointed out, I forgot to say earlier, in the D column, where you've got 3, 1, 4, 1, 2, 2, etc., they're all minus numbers. They're minus numbers because the numbers in the post-drug condition are higher than the numbers in the pre-drug condition. If the numbers in the pre-drug condition were higher than the numbers in the post-drug condition, those numbers in column D would be plus, would be positive, rather than negative. The negatives and the positives show you which direction A is condition A higher than condition B, or vice versa. They just indicate the direction of the pattern. And if the two numbers in condition A and condition B were exactly the same, then the number in column D would be 0, which is a neutral number, neither higher nor lower. Just 0. It's exactly the same. So far, hopefully, so good. Now, the table of numbers there, you get that out of the back of various statistics books, and you can find them online. I nicked this one offline. This gives us the degrees of freedom. Now, we went over the degrees of freedom last week, but possibly you might have gotten that. So degrees of freedom is normally written as DF, the way it is in the box on the left-hand side of the screen. So to work out the DF, the degrees of freedom, you take the number of participants, N, and you subtract 1. You always subtract 1. So there are 10 participants. 10 minus 1 obviously is 9. So degrees of freedom is 9. And on the big table on the right-hand side of the screen, on the left-hand side of that table, at the top in the box, it says degrees of freedom, and you go down to where it says the number 9. And that's the part of that table you need to use that line across from there. Now we need to decide what level of alpha score is correct. So we're going to do the standard thing of going for 0.05, because that's the normal thing you do with most experiments. There are occasions when you'd be using one of those other columns, but the standard practice for most statistical packages is to use 0.05 for most experiments. So we don't need to worry overly much about the other columns on that table at this juncture. So you found the number 9 in the column degrees of freedom, and you read across to where it says 0.05 in brackets at the top of the column, cross-reference, and what you'll find is the number 2.262. That's the magic number we're using, 2.262. Okay, so the t-test, the t result, you'll remember, was minus 10.67. Now, forget the minus bit at the moment, because the minus bit is only there to indicate, as I say, the direction of difference. That in this occasion, it's condition B that is higher than condition A, rather than the other way around. So it's just 10.67, that's what we need to focus on. Now, 10.67, in order for this experiment, this research to have proved something interesting, has to be higher than that number we just found on the table of probabilities at the 0.05 level. The number, of course, was 2.262, and obviously 10.67 is higher, bigger, than 2.262. So we crack open the champagne, dance on the tables, go woohoo! And so look, we have discovered a statistical significance here. So we reject the null hypothesis and we uphold the hypothesis, and we can state that people who take these Brainiac pills definitely see an improvement in memory. It gets higher. Column B, condition B, is higher than condition A. Therefore, for this bunch of people, at least, we can say that the Brainiac pills work. Now, we can't necessarily say that Brainiac pills would work for absolutely everyone on the entire planet, because that's a bit of a grandiose claim. There may be some people in the world for whom it doesn't work, and we might want to go out and do a lot more research on much larger numbers of people than just 10 people to find out if it works for, say, men versus women, different age groups, different ethnicities, different this, different that, to see if there are wider uses in a much, much bigger population of human beings than just 10 people. But for the purposes of this imaginary experiment, we can say we have proved that the pills are useful for improving memory. So far, hopefully so good, and that's pretty much where the maths ends for today. So if you want to go and pour yourself a very strong coffee or stiff gin or whatever you fancy, breathe with a sigh of relief. We'll now move on to some language theories. This is going to be quite a short bit, because only some of these theories will necessarily be relevant to the type of experiment you're conducting. So last week we mentioned Noam Chomsky, American theorist. This week it's Lev Vygotsky, Russian theorist, from the turn of the 20th century. Died very young, unfortunately, then, before he got a chance to develop his theories even more. And it's the Russian government wasn't very sympathetic towards him. They favoured a different theorist. They were very keen on Pavlov, and they didn't much like Vygotsky's ideas. So his books languished in cellars and dustbins and things for quite a long time before he became popular in the West, and these books were translated into other languages. And even if the Russian government didn't much like Vygotsky's ideas, plenty of other people around the world did. So he became more popular after he was dead than when he was alive, unfortunately for him. But there we go. So what was, he had lots of ideas, but what are the key ideas that are related to language rather than all of these other various ideas and other things? Well, he says when it comes to language, and he was mainly talking about children here rather than adult learners, but we can still apply the ideas across to adult learners as well as kids. He says the traditional idea of teaching, bearing in mind we're going back to the 1920s and the way schools operated back then, and during decades earlier than that, when Vygotsky was growing up and a schoolboy himself at one point. So the style of teaching back then was what's termed instructionist. So the teacher stands at the front of the class and says, "Right, class, today we are going to do our 3 times table," or whatever it might be, and dispenses the information. 3 times 3 is 9. 3 times 4 is 12, and so on and so on. And the students either sit there very quietly and write it down, or sometimes they might just repeat it, parrot style. But there's not much discussion. So teacher says stuff, students nod their head and go, "Oh yes, yes teacher, you're right teacher, oh yes," and absorb the information. Vygotsky said, well, it kind of works for a point, however there are better ways of teaching. So Vygotsky said children, and we can argue adults as well, learn best through a social environment of interaction, where they're not just sitting there quietly trying to memorize things, where they are asking questions, they're discussing, they're chatting, they're bouncing ideas around, where they are also to some extent directing the exploration of ideas. So let's say, for example, we'll stick with the language issue so we're going to keep on track. Let's say the teacher wants to get the class to learn words in Korean, for argument's sake. And so the teacher starts saying, well, here's a few words in Korean. And the students go, oh, that's interesting. However, teacher, I really, really like animals. I like pets. Can you, instead of teaching us the words on the blackboard, can you teach us words about animals? What are Korean names for different animals? How would I say to my dog in Korean, let's go for walkies? And so the teacher then responds to the students' interests. And although the teacher is still perhaps saying, well, we also need to learn this word as well, for whatever reason, they're also trying to keep on the ball with what the students are interested in and follow the students' level of interest. So if the students are really interested in pets and animals, they might learn Korean words for different animals much more quickly than they would learn Korean words for days of the week if they are not particularly interested in days of the week. So maybe eventually they would have to learn the days of the week, but the idea is you get the students' enthusiasms and you run with those, and that gets them really engaged in the learning and is more effective at them taking on board stuff, absorbing ideas, than just the teacher says, right, you've got to learn this, now sit there and shut up while I tell you the information. Also things like conversation. So how do you best learn a language? By trying to use it, by talking to other students in Korean or whatever the language might be, by talking to the teacher in that language, and the teacher occasionally saying, well, actually you've mispronounced that word, it's said this way, not the way you just said it. So it's an interaction and engagement rather than just sitting there with the teacher at the front of the class reciting words and everyone in the class nodding their heads and writing them down or parroting them back to the teacher. So what he also develops is this idea of the ZPD, the zone of proximal development, which is a slightly weird way of saying students learn best if they have someone who understands the subject better than they do, as the teacher, and that teacher also pitches the lessons slightly above where the students are in terms of their understanding. So it will be no good taking a 10-year-old doing their first ever chemistry lesson and the very next week expecting them to answer questions from a PhD exam paper, because that's way, way, way above their zone of development. It's far too high. So instead, a good teacher would work out, well, they know the first lesson, this simple lesson, so we just need to, for the second lesson, step it up a very little bit, so they learn a little bit more, and then the one after that a little bit more, and the one after that a little bit more. So it's not throwing someone in at the deep end and expecting them to swim, It's just doing it little bits at a time, little chunks at a time, bit by bit by bit, to try and get them to understand something. That's Vygotsky's idea, and how this differs from Chomsky's idea is Chomsky says language acquisition is biologically driven. Our brain is structured to acquire language, and even if we just sort of sat there like lemons, we would still develop language because our brain is geared to do it. And there are cases, which Chomsky can point to, of very, very neglected children who have had very little support or love or care from anyone, who seem to have developed their own kinds of language. And indeed, even in situations where the children are still well cared for and looked after, particularly with identical twins, it's not uncommon for identical twins at a very young age to develop their own language, which is not the language of their parents, but their own kind of weird twin language for different ideas and different things and different objects. So no one has taught them that language, it's just sort of spontaneously developed. And this is the kind of thing that Chomsky can point to and say this is evidence that it's the brain and the organic structure of the brain that drives language forward. Whereas Vygotsky is saying it's not so much the brain, it's social interaction. So if you dumped a kid in the forest and they were raised by wolves, they would have no social interaction from human beings, therefore they wouldn't develop language. Vygotsky is also keen on this idea that there are certain periods in a child's life when it's very important they get the input. So if they don't have any input in that period because they're being raised by wolves in the forest, then even if the child is found at an older age, that older age may be too late for them to effectively develop language. And there have been abandoned feral children raised by wolves or chimps or what have you, who get rescued years and years later, and who frequently struggle to develop language, human language. Is this because they missed that key period in their life when language needed to be developed? Some people have said, yes, this is evidence of Vygotsky's idea of social interaction. They didn't get the social interaction, so now they struggle to grasp language. And other people have, possibly slightly more cynically, suggested that maybe one of the reasons why these children were abandoned in the forest in the first place was because they were perhaps brain damaged in some way. They had severe learning difficulties, their parents didn't know how to cope, and so they just dumped them. And so when the child is found at the age of 10, 12, 15, whatever age they may be, by the time they're found, the reason they can't learn language very well then is not so much that they missed that key phase in their life, but more to do with the fact of their brain damage and their severe learning difficulties, that they would never have been able to learn language well or at all, even if they had been raised by human beings rather than being raised by wolves. It's all very theoretical because obviously you'd have to do some horrendously unethical experiments to put that one to the test. Now, how could you apply Vygotsky's theories? If you want to apply Vygotsky's theories, you don't have to, but if you want to apply Vygotsky's theories in your experiment, you could have one group trying to learn a set of words by rote. Just teacher says it, class repeats it. Do they learn well that way? After, let's say, 5 minutes of teacher says it, class repeats it, teacher says it, class repeats it. And another group of people who are learning a 10-word sentence which they can use in conversation. How are you today? Oh, thank you, I'm very fine. That sort of thing. So rather than just learning 10 random words, they're learning a form of conversation, and once it's explained to them, they can then spend that 5 minutes engaging in repeating those phrases to other people in the class, so students interacting with students rather than necessarily the teacher, and utilising it as a conversational sentence rather than just 10 random words. So you get two groups of people. One group does it one way, one group does it the other way, and then you give both groups a break. So let's say for 3 minutes they sit and listen to some music being played to them. So they don't say anything, they just sit and listen to the music. They're not writing anything down, they're not talking to each other, they're just sitting there. And then after the music has finished playing, then you test them on how well they've learned the words. And that test could be they have to say it verbally, or perhaps they have to write it down, depending on how the case goes. So who remembers the 10 words best? Group A, who learned by parrot fashion, or Group B, who learned by the socially interactive fashion. That could be one way of doing it. And then you score them on how many of the 10 words did they recall correctly. It's an option. Now, nearly finished. So, I was going to say a brief recap. We haven't really touched on Skinner in this one, but you have looked at Skinner in other modules, so it is a bit of a recap. Skinner, the behaviourist, believed that language is chiefly learned through operant conditioning, in other words, a reward system. So, a young child says, "Oh, look, Mummy, a cat." And Mummy pats the kid on the head and says, "Oh, well done, you remembered cat. You said cat correctly. Well done, you." And that's an emotional reward. And so the more reinforcement, the more pats on the head the kid gets, the more inclined they are to remember the words that they're being patted on the head for remembering. How could you convert that into an experiment? Well, I wouldn't recommend the patting on the head thing, because people will get annoyed at that if you do that to adults. But you could have, let's say, one group of participants who are set a list of words to remember, and there's no reward, nothing, they just either they remember them or they don't, end of. And another group who are told for each word they remember correctly, they will be given a sweet. And so there is an incentive. So will the group who are promised sweets get more words correct? Will they remember words more accurately than the group that's not promised anything at all? That could be an option. Chomsky's argument, as just said, is this idea that language is instinctive, instructional, that it just kind of develops out of our biological urges. It doesn't per se require a lot of social reinforcement, as Vygotsky's argument suggests. So could you come up with an experimental design in which, as such, there is no teacher, there is no social interaction, there's perhaps a list of words on a screen, and they have to look at them in silence for a period of time, and then maybe the screen is turned off and they have to repeat that, and you see how well they do, and then you compare that to a different style, for example, Vygotsky's style or Skinner's style. So are they acquiring words? Are your participants acquiring words because their brain is just geared to acquire words? Or does it require something extra, like social interaction or rewards or whatever, to encourage them? And you can also look at variations on this, so things we mentioned in class previously. Let's say one condition where it's just the words spoken out loud and they repeat it, and another condition in which there's a photo on the screen, a picture of the dog, and then you all say the Portuguese word for dog, and so the class are learning to match the word to the meaning of the word, the thing the word refers to, in terms of a picture. Or maybe one condition in which people say the teacher says the word, class repeats it, versus teacher says the word, class writes the word down. So does writing it down improve memory compared to just speaking it? Or does it make no difference? You could look at that as a factor. And Vygotsky, we just said, it suggests social interaction is more effective than simply parroting words, so you could compare those two styles, which I've already mentioned as a suggestion, that the one where they're just repeating words like parrots, and ones where they are trying to use sentences, stringing words together into a meaningful sentence. They can have a conversation with other members of the class. Which one works best? Where you're comparing two conditions, one of the critical factors is to make sure the conditions last for the same period of time. So it is not the case that they spent 10 minutes doing one thing and 5 minutes doing the other. Therefore, maybe the difference in scores is because they spent twice as long doing one thing as they did the other. So if they spend 5 minutes in one condition, they spend 5 minutes in the other condition. So it's the same amount of time. Therefore, the time is not the issue. It is the factor you're trying to test, the independent variable that you're trying to test. So you could look at those possibilities. So what I'd like you to do, ready for next week's lecture. Now I say next week, it's Easter holidays next week, so we've got a 3-week break. So you won't hear your next lecture, and I at this juncture, obviously I have no idea if they will discover a miracle cure for coronavirus and we'll all be meeting up back in person again after the Easter holidays, which would be lovely if we do, and even lovelier if they discover the cure, or whether we'll still be in a similar situation to the one we're in now, where it's all being done by podcast and we're all still sitting in our respective homes. I don't know how it's going to pan out, but however it pans out, for the next lecture we'll address the 1,000 word reflective piece and what to put in it and how to do it, and we'll look at a different type of t-test, and there'll be more support for your lab report. The submission date I'm looking at putting back to, I'm afraid there's a bit of an XXX there because I'm still waiting to hear on confirmation from management as to what the agreed date will be. And as soon as I hear what the agreed date will be, I will put a message on the module page telling you what that date is. What I'd also like you to do is email me over the Easter holidays, ideally at some point within the next 2 weeks would be the ideal date for me, but I appreciate that a lot of you have kids, you might be looking after elderly relatives, all sorts of things. Some of you are going to still be in work as key workers. A time slot that's convenient for me might not be convenient for you, so I'm keeping it a little bit vague, but if you can please get back to me before the end of the Easter holidays. So one person from within each group, just say, deciding your group, right, you are the one to go and contact Robin, it's your job, go and do that. And that person can get back to me and tell me, once you've decided as a group, what design are you using within or between groups design? What data are you trying to generate? So is it measuring how long it takes someone to do something, or is it measuring how many correct items they get off a list? Is it ordinal data, who scores highest, second highest, third highest, and so on? How are you generating your data? What kinds of number crunching, what kind of data do you want to create for your number crunching? And then what sorts of people, imaginary people, you would like to recruit as participants. So are you wanting to compare a group of men versus a group of women? Or are you wanting to mix the genders up? Are you wanting to compare a group of teenagers to a group of middle-aged people? Or are you mixing the ages up? How do you want to do this? And then I'll create, as I said, I'll create the numbers. Once you've told me the nature of the design you want, I'll then email you back and say, right, you had X many people in your group, so many of them are men, so many of them are women, here are the age ranges, and here are the scores your participants theoretically got, and then you go off and you use that fictional data I've given you to, not conduct the experiment, but to write up the report as if you had done the experiment for real. I'd also like to know what your test materials are, so whether you're showing them words on a screen, whether you're showing them pictures, whether you're bringing in actual objects and showing them actual objects and saying, oh look, we're now going to learn the Dutch words for all of the different types of fruit in this bowl of fruit. And you hold up a pear and you tell them the Dutch word for a pear, and then you hold up a banana and you tell them the Dutch word for a banana. However you want to do it, whatever imaginary materials you would like to use, and don't go nuts. Just because it's imaginary doesn't mean you can go completely Fruit Loop and start wheeling in things you couldn't possibly wheel into a classroom. So we're trying to keep this theoretical experiment as close to the real type of experiment you would have actually done if we weren't all stuck in the coronavirus situation. And then once you've told me, I will then feed back to you with the data, and then we can get on with number crunching it. And I'll also tell you what style of statistic is most appropriate to the design and data that you want to use. And so you know which PowerPoint to look at if we've already done that statistic, and if we haven't, then I'll make sure there is a PowerPoint uploaded about that specific type of statistic for your experimental group to use. Okay, hope you're all doing well and speak to you soon.